All right. Hello, hello, hello. Good evening, good evening. We are here at Amsterdam and you're dreaming. Yay. Okay, so big thanks to our sponsors. Without them, this event wouldn't be possible. So, a quick round of applause. And don't stop yet. Just keep clapping for you guys as well because this wouldn't be possible without you as well. So, big thank you to you as well. All right. So, what are we going to talk about today? Slow. Come on. Make it faster. So, we all know this Salesforce sometimes can be very slow. And we will see what are the different aspects, how we define slow, and how we scope the context about which we're going to talk about, what this presentation is about. And before that, a quick introduction, who I am. So I'm a senior dev at Salesforce. It's a consulting firm primarily focusing on the DACH region based out of Munich. I'm a 3x MVP. I'm a huge flow advocate. I also blog at Force Panda, 3x Ranger. And yeah, these are my Twitter, LinkedIn handles. Feel free to reach out. I'm more than happy to engage in a conversation. All right, so let's define slow because Salesforce in general is huge. And there are so many aspects when we call slow. So it can be a page load time, it can be a record trigger time, it can be CI/CD. So there are different aspects to when we call it a slow, when we call our Salesforce org slow. So primarily, there are two aspects which are oftenly talked about and which are very user-centric, and business is always kind of interested in those things. One is page load time, and the other is record save time. So how many of you here have seen your records taking time or too much time, maybe let's say 5 seconds, 3 seconds, or yeah. So let's get an average number. How much time do you think it's 5 seconds, 10 seconds? What's the max you have seen? Yeah, so the fact that it's common speaks a lot. And we need to really address how we can solve this problem because at the end of the day, you will be building a lot of logic going forward. And now we have so many things, flows. So it's easier to just place automation without really thinking because it's so accessible to not just developers, consultants, but also admins. So we need to be a little thoughtful about how we are going to design the logic. So we are going to scope our conversation today to record save time. And let's quickly develop on this fact, what makes our org slow. So there are different aspects of it can be technical debt, inefficient code. So a quick look at the things that make our org slow. So technical debt, it's very easy. We know if there is a automation which is not necessary, but it's still running in the order of execution, it takes time, and that makes your org slow. Hardware problems, if you have slow internet, lousy laptop, of course, then you will face issues. Integrations also, to a large extent, takes time. When you have a lot of integrations going on, you can have batch executions, then your batch processing also gets slow. Your Apex Flex queue gets slow. You have processing, async logic getting processing. That's also impacted. And data volume and quality, yes. So this is primarily very important when you have huge data, you have list views getting impacted, your reports running very slow, taking ages to load, and then you are going to different solutions to fix those issues. Managed packages, probably the worst, because you can't control them. So yeah, and finally, inefficient code, something which you can control and build your solutions around that so that it can be more effective. And that's where we will scope our discussion around. So inefficient code, we will talk about low code especially because that's the future. That's where the platform is going. So it's a really good time to have this conversation about how we want to design a solution or low code solution so that it's scalable and also it's maintainable, and what are the best practices around that. So record triggered automation are very famous nowadays and has been on this platform because it's so easy. And now there are two important things that we need to consider, which is when we are selecting or talking about the choice of execution context in record triggered automation. There is before save and after save, and we will quickly discuss later what is after save and what is before save. And then on the other hand, we have asynchronous and synchronous logic. For those who are new here or may not be familiar with asynchronous and synchronous, think of it as you click on the save button, a thread runs, the logic is saved. Now, in Salesforce, we call this a transaction, and anything in that transaction happens, we call it synchronous transaction. So transaction is just a set of commands that is being executed one by one. So what happens is, if your transaction or too many commands, in our case, we will have too many automation around the object. So what happens is, if you have too many things going on in the same thread or same transaction, you will see that the record load save time is impacted. And in asynchronous, what we simply say is, asynchronous is something we don't really care about. We can process it in the background, and we can throw it in the background. We don't need to see the immediate results. It can be handled or put into a separate thread and may not necessarily be in the same. For example, you can have emails. You don't really care about emails are sent in the execution, same execution. It can be sent later or stuff like that. So yeah. So let's start with synchronous and asynchronous. So if you let's take a look at general automation architecture, where what we see in our daily lives. A very simple use case. So imagine we have an opportunity, and we want to implement this use case. We have a stage opportunity object, and we want, when the stage is updated to negotiation, we want to create a task for client care manager, where this client care manager is a field, is a custom lookup to the user object on the opportunity. So how would you normally do this? Very simple. You will create a flow where you will put in some conditions and create a task, and then, yeah. And all of this happens in a synchronous cycle, yeah? So the thing is, if you implement this, and this I did it in a fresh developer org, it takes about 200 milliseconds. Now imagine when you combine all of those automations running in a asynchronous cycle, this number keeps growing and growing, and it will continue to grow. So what this tells us about this architecture is, it's synchronous. You have just one thread running. Everything is happening in that transaction, which makes it very slower. And then, again, it's very tightly coupled. You can't take out the logic and put it somewhere else or reuse it in some sense. So we call it very tightly coupled in sense of when we talk about software architecture in general. So let's introduce the decoupled or the asynchronous automation architecture. What happens in that sense? So the same use case, we could have implemented it differently. So the way we use it, or the way we can do it, is, for example, in this case, we know that task is not for the user who is updating the opportunity, is being assigned to someone else. So the running user would not be so concerned if the task is created. We want to create the task for the client care manager. So what you simply do is, you take out this logic, and either you use a scheduled path or you can use a platform event. I tend to use platform events because they are way faster, but there are some here and there pitfalls. We will talk about that. And then, yeah, and you save so much of time. That's the best part, and that's the whole point. We want to make it faster for us, for our end users. You don't want to keep seeing that loading spinner and spinning. So, yeah. So this is how a normal decoupled async automation architecture would look like, where you take some logic and put it in an asynchronous thread. The choice of a scheduled path or a platform event depends on the use case, and we will see what are the different things that you need to be careful when you are specifically using platform events. But yeah, so quick characteristics. It's asynchronous. You will have multiple transactions. You can have a lot of logic which is happening in different asynchronous threads. It's decoupled. So if you want to call a logic from somewhere else as well. For example, we have the concept of subflows. So it's decoupled in that sense, so it's easily maintainable as well. And then it's faster, of course. And the best part is it's easy on governor limits. You get a fresh set of governor limits. Although the thread will be synchronous, it's not like Apex where you have async limits applying, but still the fresh set of limits really helps. And that way you can put your heavy lifting where you have complex processing going on. You can put those in there, and the processing doesn't affect the real-time user interface of your end user. So quick considerations and best practices about when you are using the platform events, because it's not so simple when we talk about platform events in general. So platform events run asynchronously. So what happens is when you design your solution and you don't want to see the results in real time, what is going to happen is, only in that case it would make sense to use platform events. So if you have something where you want to see the result right at the page, right after the page refresh, then platform events or asynchronous logic handling is probably not a good fit in that case. And platform events typically can be very hard to debug because they are running in the automated user context. Now for that, you have to create a debug log. You have to or you create a flow where you handle the event. But yeah, so you have to put a debug log on the automated process and then go through the logs. So this is typically a little difficult. And then you have to have error handling. So what you can do is you can put all those errors. What I typically do is I use Chatter a lot. And we have groups where you can have errors related to platform events or a typical, or let's say, order management cycle when we have a lot of automation going on asynchronously just to monitor what is happening. Because in low code, it's very difficult to have an error framework in place. So unless you have a very robust framework already that you can use, and let's say you can call it via invocable methods, you can easily use Chatter for those kind of error messages and error handling. Yeah. And it requires time. When we talk about platform events, there are so many small things associated with it. So I would, if you feel that you want to use platform events, try and do a bit more research in terms of how they are handled by the platform, what are the streaming API limits. The best part is flows that are invoked by platform events are not counted against the limit. So that's good. But again, there are still so many use cases, for example, debugging and all those stuff. So if you have a team who are not very well versed with debugging, they don't know debug logs too well, then you might have to make a choice if you want to really go with this solution or not. And yeah, limits can be confusing. We can definitely even have a talk about this, because subscription, delivery, these are the terms that normally admins do not in their day-to-day life come across. So for them, it can be really tricky or very confusing or even overwhelming at the beginning if they have too many terms coming in and you want to use this solution. So it's really important when you have a team, you have to think about how this solution is going to be maintained as well down the stretch. Okay. So I talk a lot. 2 years it has been, what can I say? So, okay, yeah, some best practices. When you are creating a platform event, there are two choices you are shown up. One is immediately create the platform event, and the other is after commit. So basically what this means is when you want to create a platform event, you can create a platform event within the transaction even without the transaction is complete. So if you have a use case like that, feel free to use it. But I would recommend for your general record-triggered automation, try and use after commit so that your platform event is only fired when the transaction is successful and the logic is only executed when you want it to execute. So you would know it's executing. Implement extensive error handling. The reason is like I said, debugging is very difficult. So you want to post those error messages somewhere you can easily go to and check. You don't have to go to the log, see what's failing. So it's good to have those error handling practices in place. And yeah, try avoiding use cases where automated process can be a problem. For example, you can't really sometimes access or give access to the stuff for automated process. And also sometimes what you will see is a lot of logic is being used by automated processes, and you don't want to extend that permission, so that you want to keep the platform secure. So in those cases, try and avoid the conflict if you can. And you can then, if you don't want to use platform events, you can use the scheduled paths in the flows to tackle that issue. And yeah, last but not the least, limits, platform, multi-tenant architecture. So review your current or consumption limits, even though your platform triggered flows do not count against the limit, still you should consider, because the delivery, or sorry, what is it? Yeah, I'm forgetting the term, but yeah, there are two terms where you create the platform event and then there is a delivery limit. So the creation is still being counted against the limit. Although when we deliver the event, that limit doesn't really count. Yeah. Now, going back to the choice of execution context, we discussed asynchronous and synchronous, but we didn't really discuss the second part, and which is up next, is before save and after save. Quite fast on time, okay. Okay, so before save and after save, what does it mean? So a lot of newbie, especially admins, do not come across these terms in their day-to-day life, but now these should be your best friends, because you are going to be creating a lot of flows. So what happens is, in a chain of transaction, there are some checkpoints, and before, we will quickly take a look at them. So just to show you what before save and after save looks like in a flow, and I'm not really happy how Salesforce has named these, because it can be very misleading to normal admins. Oh, this is fast field updates, fast, yeah. so, so it's very misleading. You can take the mic. He's just messing with me. Yeah, so fast field updates, it basically means before save, and we will just take a look at this, what before save means. And action related is after save. So what is before save and after save? We have seen this a lot, and we hear this a lot as well when we talk about flows. So order of execution, meet admins, your new best friend, order of execution. This is important now in the context, because you need to know what is happening in the order of execution, how your flows are affecting other automation as well. So this is a brief snapshot. I've tried to categorize order of execution in a very plain and simple way. So what happens is, the transaction starts, you hit the save button. So these are the steps that happen in the order of execution. So before save, so you have flows before triggers, and then validation rules. So these are the things that happen before your record is committed or saved to the database. And what happens after the record is saved to the database is after save processing, which is after triggers, workflow rules, process builder, and after save flows. So the difference is, for example, if you have a field, ID field is not generated in a before save context. It's generated in the after save context. It doesn't mean the record is saved to the database, it's not committed to the database, but it's saved to the database as an entry. And then finally, in all this information after all this processing is committed to the database. And post that, we have email and job enqueuing. So all of those logics are processed after committing to the database. So this, in a nutshell, how order of execution looks like. So this basically gives you a good understanding of what before save flow is and what is after save flow. So what is the comparison, or how do we define when to choose, and how do we find a winner among this? So if you just look at the numbers, before save flows are 10x faster than after save flows. And it's not rocket science. Salesforce just says it's very fast, but they do not really explain the meaning why it's faster. So what happens is, if you just go back to the order of execution cycle, for example, if you want to update an opportunity which is getting updated in the same transaction, if you do it in the before save, you are not committing to the database, or the record is not getting saved to the database. So we are changing the record before it saves to the database. But if you do that, if you do the field update in an after save context, it is considered as a DML. What DML means is just you repeat the save cycle again. So what happens is, your whole order of execution cycle for that specific update reruns. And when you have so much of automation around the object, it just continues to grow, and there are so many recursive cycles happening one within. So yeah, a spiral circle. So that's why the before save flows, if you make an update in before save context, you skip the part of going over the execution cycle or order of execution again. So this is why the reason before save flows are 10x faster than after save flows. So all those updates that you want to make to the record, which is in the currently being updated, you should try and use before save flows if you want to make updates to the same record. So this brings us to an important question: how do we choose which context we should use when it comes to before save and after save flows? So like I said, when you are making updates to the same record, try and use before save flows. But when you want to make changes to the records that are not that are related to the, for example, you want to update opportunity contact role when an opportunity is updated, you want to do that in the after save context, because you can't do that in the before save. As simple as that. So yeah, and then you have emails and all that stuff, which is Flow has done a really good job that it doesn't allow you to just send emails in before save context, so your capabilities are limited as in that term. But yeah, this is why you want to do this in before save and after save context. So this should help you. But if you see, there are two asterisk signs, because there are some use cases where you can't use before save flows even if you want to make updates to the same record. Any guesses? For example, ID field is not generated, and if you want to use that ID, send it to some, let's say, external system, or just update it to some external field. In that case, you want to use after save flow, because there is really no choice. And for example, formula field is calculated in after context, after the record is saved to the database. So all those evaluations, auto number field. So all these fields you have to be careful when you are using, because you cannot use before save flows for these fields. So yeah. And then a quick pro tip when you are building new flows, because this is new, everybody is generally excited about new features. You have formula entry for entry conditions. How many of you are excited about and looking forward to use it? Yeah. Okay. Hold that thought. So basically, the issue with this, like I said, be mindful about is, it takes a really significant performance hit when you use formula entry conditions. So the reason is how they have built it. I can't explain it. It's just Salesforce proprietary technology. But yeah, just the brief understanding, just to create this whole or load the set of functionality to evaluate the criteria or evaluate the whole criteria that you set up, it takes a toll on the performance. So if you have a where, if you just want to use a match where stage is updated to something, just use is change operator and the field value instead of going to the formula builder straight away and using this as your default option. Yeah. And one more thing which is not documented and even Salesforce doesn't know it. I mean, now they know it because I told them. So, yeah, so basically, you have a record type field and you want to fire that automation on based on the record type. Yeah. So typically, you would do this in aftersave because you can't simply check the record type if you remember in the previous entry conditions, you can only select fields. And you don't want to hard code the ID, of course. To some extent, you want to remove all the hard coding stuff. So you would create a field, you would do this, either you create a decision node or you do it in aftersave, but you can't set it in the entry condition for the flow builder. So that limits your possibility, but it's very interesting that it works. So what you can simply do is you can create a formula field that just takes the developer name or name of the record type and use it in a before save flow, and it works. Magic. And I told Salesforce, even if it's a bug, don't fix it. Yeah. So, yes, and I just, for the sake of a little demo how you use platform events, I want to show a quick demo how we can use platform events and use that or plug it into our Salesforce and use the async automation handling. So let's switch. So I have this flow which normally looks like this, where I'm. Ooh. Okay, got it. Now it should work. All right. So typically to refactor this logic to create a task, what you can simply do is you can create a platform event. And just to quickly go through this flow, what we are doing is we are firing this flow when the stage is changed to negotiation review. And we use actions and related records or after save. And we then simply create a task. Normally, we will do it like this, but you don't want to do this and you want to save every inch of that millisecond you can get in that transaction, because trust me, at some point you would need it. Okay, so this is the, let's say these are some parameters that we want to send. So that's how we will design or create a platform event. For those who are new to platform events, think of it as custom object with a suffix __ e. And we will see how this looks like. So let's say task creation. For the lack of a better name, I'll just use task creation. And like I said, always use publish after commit. And you don't want to use publish immediately unless you have a really good use case or strong use case for this. So this is how your normal platform event would look like when you create this. And then you can add your fields so that you can send in some information to the platform event when you are firing the event. So let's quickly add a field. Subject. Then let's add what ID, because we would need the what ID to associate the task back to the opportunity. Okay, so now we are all set. What we really need to do is we need to refactor this flow and say fire the platform event using this flow. So firing the platform event is as simple as creating a record for an object. So how this would look like is, let's create a new flow. Didn't change. My bad. So we want to change the type when it's executed. So we want to use the platform event triggered flow, and we hit save. We will see some errors because we can't use object account. Oh, it doesn't work like this. Okay, so basically we will create a new flow. I was expecting it would work like this. Hopefully this should be quick. So your platform event will show up here when you see. So we see our task creation platform event. That's how you choose a platform event. And then you simply, I can never get used to this UI. So simply we just create a record. We say fire event, and we use our task creation event handler. Say subject, follow up, and what ID comes from the record ID. Yeah. Correct. Yeah, we have to do this. Yeah, subject. Let's call it record. So this record will hold all the incoming values that are associated with the platform event. So we will use subject from here, and then what ID, record, what ID. Yes.
Before you use the custom fields that were created on the platform events. Please use the microphone. Yeah, sorry, but there was no microphone. Before
Yes.
you, sorry, I have a question. Before you showed, you used the platform events. On the platform event, you created 2 custom fields, and now you're just using the ones that are already on the object itself.
Actually not. So if you look here, we are creating the task from the values that are coming from the platform event. And now we will see how we will fire the platform event. So at the moment, what we are trying to do is we set up a flow which handles the incoming event, the platform event, and then we create a task based off the values we receive. So in the task platform event, we will send the subject and we will send the what ID. So this flow assumes that this is the information you will get.
What is misleading is that it's written record, but it is in fact the events. The
Yeah.
events.
Yes.
Thank you.
Thank you, Philip. So just to clear confusion, you see it's not a record object here. You see an event. So this flow essentially, or the record entity, like Philip said, represents a platform event. So you save this. You can call test, my favorite word. And then we activate this, and now we want to refactor the flow which we had to fire the platform event instead of creating the task directly. So here we create the platform event. So we say fire event, task creation. Here we will see the fields that we want to send information. Subject, let's call it follow up, what ID, record.id. So what ID will hold the ID of the opportunity which is currently being updated. And this is how you would normally set up your whole automation around the platform events. And we can take it for a spin. Let's see. Do you want to? Okay, so let's go to sales. Demo gods, are you listening? So let's create opportunity. Again, test. Prospecting, close date, 18th, save. And you see here there are no tasks. And let's try and update the stage to negotiation. Save. It worked. Everything worked. But we don't see the task yet because it happened asynchronously in the background. So if we refresh here, we should see a task. So yeah, that's how your demo is finished. Yes, thank you, thank you. And with that, wrong slide. Okay, yeah. So with that, we come to the conclusion and we open the floor for Q&A. Thank you guys. Any questions? No question? Yes.
Hi.
Yes.
Is there a good way maybe to track what could be causing the page load to be slow? Like, is there any way you can get a breakdown or anything like that to actually figure out what you might be able to do asynchronously compared to synchronously?
Good question. When you say page load typically means when you are loading the page. So are you talking about page load or are you talking about saving the record?
I guess both. Is there any way that you can do that for both?
Right. Okay, so let's break it down. Let's talk about the record save time. So when you are saving the records, a debug log is typically generated. And you can analyze this debug log in the dev console or in the VS Code to look at what automation is consuming what amount of time in the given transaction. And for page load time, we have this nice little feature. When you click on edit page, it shows up how much in what components there are and what is the average time the page load takes time. And then also it gives you some recommendations based on what we are doing in the page. And to optimize this, what you can do for the page load, you can do conditional visibility. So if you have less components, obviously the page load will be faster. And another thing which is good to have is you don't want to put a lot of things, which I have seen is a lot of components under just one section in the tab. You typically see this. You want to break them into multiple tabs because when you click on the tab, all those components are loading. So that takes a bit of more time. But if you break it into singular tabs, it's much more faster and good UI experience. So yeah. And just to finish up, and for the record save time, you have to just drill down your automation, what exactly is happening. Based on that, you can, if there is a scope of optimization, based on that, you can do your optimizations.
Do you also count the front-end time or just the back-end? Like what you talked about right now, it's plus from the debug log, right? But on the front end, do you open like Chrome developer tools and see what is the load time? Because maybe sometimes JavaScript or something is loaded. So when you calculate the load time, do you add both? And is there
for the record, like page load time?
Yeah.
So I usually use what is already on the platform. I don't do the thorough analysis. I'm not so amazing at front-end development. So yeah, so what typically platforms shares that, oh, hey, this is very slow, this is moderate, this is also,
Yeah.
I would assume they are doing their good job.
Okay.
So yeah, for starters, you can start with that. And then if you want to,
I connected, we talked about it, so we had an issue and I had to show, based on platform events, I have to show like a pop-up on the screen. And I used like developer tools to debug the platform event. So there's an Aura component, it's on the page, something happens, I need to show the pop-up. And we talked about it and Narender also suggested the idea. So I use platform events, but also debugging the front end. I'm also now thinking I can see how the page is loading and what is happening actually, and maybe I can improve some stuff.
yeah.
So.
Yeah. What I really like is in Experience Cloud. Yeah, I'm getting it right. Okay. So in Experience Cloud, there is something called progressive rendering. I would hope at some point they would bring it into the platform as well, because that lets you allow to choose which component to load first and which components to load later. But yeah, it's not available on the platform yet. Hopefully later. All right. No more questions? Then we see each other at keynote then. Adios. Thank you.